let's finish off law of sines. Has anybody done any of these law of sines problems from the homework yet? You have? Are they going pretty well? Okay. Do you understand it's one solution and two solutions? All right, very good. So let's just go quickly. We have here, this is going to be one solution. So we have the sine of A over A equals the sine of B over B, right? So let me just draw a triangle here. So I'll make this A, B, C. So small a is equal to 3. Angle A is equal to 40. Well, really bad triangle. Definitely not to scale. And side B is 2. All right? So now I have, well, the sine of A, so I have the sine of 40 degrees over A, which is 3, is equal to the sine of B, which I don't know, over 2, right? So, Griffin, how do I solve this?
Well, we know the sine of B is opposite over hypotenuse. So it'd be like sine 40 over 3 equals...
This is not a right triangle. This is not a right triangle. Let me redraw it so that you know it's not a right triangle. Law of sines does not apply only to... This is the first time that we're now seeing things where the triangles are not right triangles. That rule only applies to right triangles. Do you understand what I'm saying?
Yeah.
Okay, good.
I mean, I'm not sure what I need to do differently.
Well, you can't say that anything about the opposite and the hypotenuse anymore. Not for that only applies for right triangles. Because we don't have a Pythagorean identity either. That only applies for right triangles. Do you understand?
All right, so no more SOHCAHTOA and no more Pythagorean identity.
Not for law of sines. I mean, definitely it still applies. Anytime you have a right triangle, it applies.
Mm-hmm.
If they said A equals 90, we're good to go. But they didn't. So the only thing I can do is I can use the law of sines. And now I have to solve for B. How do I solve for B? Capital B. It's just algebra here.
I'm trying to look up the law of sines.
I'll give it. You don't have to look up the law of sines. I'm right here. There's no need for notes. I'm right here. The law of sines says sine of A over A equals sine of B over B equals sine of C over C. That's all the law of sines says. Okay?
Uh-huh.
So I wrote this equation here because I used the sine of A, which is 40, over small a, which they gave me is 3, is equal to the sine of B over small b, which is 2.
So we cross multiply?
Okay. So
like sine B3 is equal to sine 42.
So I have 2 sine 40 equals 3 sine B. Okay.
Divide that by 2.
Divide what by 2?
Both sides by 2.
Why?
No, we want to get the sign b by itself. So
Well,
divide
I just want to
both
get b
sides
by
by 3.
itself. So I have to divide by 3, not 2.
Uh-huh.
Now, how do I find b?
Okay, so sine of b is equal to 2 sine 40.
But I need to know what b equals. I want b equals something. How do I find that?
We need to figure out what sine 40 is.
Doesn't matter. That won't help me with b. How would I find b? Let's say, for example, this number here is 0.62. It's not. I just made it up. How does that help you?
Okay. You know b is equal to sine
No,
0.62?
sine of b is equal to. So this is a value.
Okay.
This over here gives me a value. Wait, hold on, let me get my pointer. This gives me a value. What is b? Is b going to be a value or an angle? No, it's an angle.
Value.
I
No,
always
it's an angle.
take, like, say, the sine of some angle, 30 degrees, right, is equal to some number.
Mm-hmm. Yes.
So I need the angle.
Right.
Who knows? Yes, Kirsten, how do I do it? I take the inverse sine. I have to take the inverse sine of both sides. So I can say the inverse sine of 2 sine 40 over 3 is equal to the inverse sine of the sine of b, right? These cancel and gives me b equals, and now I have to put this into my calculator. Does anybody have a calculator handy, or do I need to do this? Okay, perfect. Thanks, Luis. So I know now b is equal to 25.4. Okay? So, oh, I have a lot of mess here. Let me get a new page. So I have, let me make my chart, because I want to see if I have one triangle, two triangles, or no triangles, right? So I have A, B, C, small a, small b, small c. I know b is equal to 20, nope. I know, let me put in heart in black. I know a is equal to 40, that's given. I know little a is equal to 3, thank you. And little b is equal to 2. These are given, right? So now I have to say, well, we just calculated that b is equal to 25.4, and what's the other angle it could be? Exactly, 154.6, which is 180 minus that. So this, if I look here, there's no way I can have a C. This is already 194 degrees, right? So this, I only have one triangle here. And this is 165.4, so 166, 70, 80, so 114.6 would be the other angle of the triangle. And then I could calculate C by doing sine A over A equals sine C over C, and solving for that. So Griffin, did that make sense to you? Do you understand that?
Yeah, that makes more sense.
Okay. Is there any questions about this? Well, if this is a triangle, then 40 plus 25.4 plus some x, or angle C, is equal to 180. Okay, perfect. Any other questions? All right. So I'm not going to do this one. It has two solutions. It's just doing exactly the same. I do want to do this one. This has no solution. So I want to show you what it looks like when you have no solutions, just so it doesn't panic you. So here's A, B, C. So A is equal to 2, and C is equal to 1, and this capital C is equal to 50. So again, I can say the sine of C over C is equal to the sine of A over A. So that means I have the sine of 50 over 1 is equal to the sine of A over 2. Or I could say that A is equal to the inverse sine of 2 times the sine of 50. Does everybody understand that? I just did all the arithmetic all at once. Do you have a question, Kirtan? No? Okay. So, do you have a calculator, Luis? It gives me an error. Because, what is the sine of 50, Luis? Just sine 50. 0.76. So this is 2 times 0.76, which is more than 1. So we can't take the inverse sine of something greater than 1. So this has no solution. Which basically means if I were to draw this triangle closer to scale, it would look more like, okay, so let's make C equal to 50. I'll say that's way probably more than 50. But let's say this is C, and then let's say this is A and this is B. Well, this is 2, but C is only 1. So as you can see from this picture, they don't connect. I can't make this into a triangle because the sides don't match up well. And that's why we have this no solution. Does that make sense? Okay, good. So any other questions that anybody has? Because I think pretty much this is the end of law of sines. We can solve this, but again, it's really more just the law of sines. Does anybody want to do this problem? Or should we go on to law of cosines? I don't really care. I don't know if you're in a hurry or not. I'm not really sure. But just let me know. Do you want to do this? Who wants to do this problem? Nobody. All right, onward we go. So now we have the law of cosines. We just have to get through this tonight, and then we'll be caught up from our hurricane. Okay? So the law of cosines basically has this formula, which I will expect you to memorize. It's not that hard if you look at what it means. So if I have a triangle, and I have angle A angle B, and angle C, okay? And this is small a, small b, and small c. Then if I want to know what a is, so let's find a. Let's think of this as the Pythagorean theorem for 1 second. I can say a squared is equal to b squared plus c squared. If a squared was my hypotenuse, that would be true, right? So there's that part. Now what I'm going to do is subtract 2, and then the same letters, whatever letters I have right here, B, C, I'm going to subtract that. And remember, it's a law of cosine, so cosine of the angle that has to do with what I'm trying to find. So why am I going through all this? Because there's 3 formulas here, and they all really say the same thing. If I want b squared, it's equal to the sum of the other 2 angles squared, whatever the other 2 are, minus 2 times, now it's AC cosine of b. So do you see how that's exactly the same formula depending on which one you want? Does everybody see this or no? Please try not to memorize 3 formulas. You see it? You see what I'm saying? Okay, good. So this is the law of cosines. And basically the law of cosines applies to things that I can't use the law of sines on. For example, look at this problem. I have 2 angles. I have 1 angle and 2 sides, but the sides are adjacent to the angle. Nothing is opposite. So the problem with this is if I try to use the law of sines, I'll say the sine of C over C. So I have the sine of C, that's 60, right? But I don't know C is equal to, and even though I know A or B, I have another unknown here, right? So notice here I have 2 unknowns. There's no way I could solve this equation. Is that clear why we cannot use the law of sines here? Okay, so when I cannot use the law of sines, I can use the law of cosines. So let's use the law of cosines here. Let's try to find C. So again I say that means that C squared equals the sum of the squares of the other 2 angles minus 2 times the other 2 angles cosine of C. Okay? So let's see, we have C squared equals, well, A squared is 4, B squared is 9, minus 2 times AB, so 2 times 2 is 4 times 3 is 12, cosine of 60 degrees. So this is equal to 13 minus 12 times, what's the cosine of 60? One half, good. So this is C squared. So this is equal to 13 minus 6, or 7. So C is equal to the square root of 7. So that's nice. I can find out what C is. And I can also use this to find out what my angles are. Right? I don't even have to. I can actually reuse the law of sines now once I find the other angle, other side. Because I don't have all the unknowns anymore. Does this make sense? Okay. Let's do another one. Do you want me to solve for all the angles? Let me just solve for one of the angles, just for the heck of it. So let's just use the law of cosines to do it. So we have Well, let's try to find B. So if I want to try to find angle B, I have to use psi B equals A squared plus C squared minus 2AC cosine B. All right, well now I have B is 3 squared is 9, is equal to 4 plus the square root of 7 squared is 7, minus 2 times A is 2, so 4 times the square root of 7, cosine B. Okay? So let's see, this is 11, so this is minus 2 equals minus 4 square root of 7 cosine B. Divide both sides by minus 4 times the square root of 7. I'm sorry. And we get 1 over 2 times the square root of 7 is equal to cosine of B. And so cosine B, here I'll put it up here. So cosine of B, or let me say B, is equal to the inverse cosine of 1 over 2 times the square root of 7. So what is it, Luis? What's B equal to? You got an error? I shouldn't though. Let me see, where's my phone? You shouldn't get an error for that. Did you write it 1 over 2 times the square root of 7? I got 1, well, shoot, let me get it in degrees. Oh, jeez. Oh, you got 79.1? Yeah. So B equals, try again, Luis. Let me see if I get the same thing. So, yeah, 79.1, that's what I got. Okay, so I now have this angle is 79. Yes. Yes, you need degrees. You should have still got an answer in radians. It would just not make sense. But you should have an answer. It shouldn't have given you an error. Okay, so it's 79.1. And then we can find the third angle, and off we go. Right? Okay. Okay, yeah, you have to put in parentheses correctly. Okay, so now, yeah, sure, no worries. So now, just to say, when you're using the law of cosines, you should always solve for the largest angle first.